Today we are going to focus on how to find the area of a triangle, and this is really going to blow your mind. On page 240 in your math journals, you'll see the following page. My big hint today is to first create your parallelogram. If we first create a parallelogram, we're going to be in great shape to then find the area of a triangle, because we know how to find the area of a parallelogram. Today we're learning about how to find the area of a triangle. So again, first we are going to create a parallelogram. Many of you guys were given a Math Masters page which asked you to cut out two identical triangles or two congruent triangles, and that's what I'm going to do right here. Next, I'm going to label my triangles A and B, just like your triangles at home should be cut out and are labeled A and B. Now that we have A and B labeled and they're cut out, it's our job to now orient or move our triangles around in such a way that we can create a parallelogram. So how can we move these two triangles in such a way to create a parallelogram? Well, if I rotate B upside down and I move it over here and line it up perfectly, I see that I've created a parallelogram. And let's remind ourselves of what a parallelogram is. A parallelogram is a polygon that has two sets of parallel sides. Here's one set of parallel sides, and here's my next set of parallel sides. And we've learned a couple days ago about how to find the area of parallelograms. We could have added up each individual square and counted them up, but we came up with a formula. And the formula to find this area was to multiply our base times our height. So the first thing we need to look at is our base. Our base is down here at the bottom, and it's nice and flat. And here's our height. To find our height, we go to the opposite side of our base and we go straight up as fast as we can, and we count our height. So to find the measure of our base, we count how many units wide our base is. We find that our base is 6 units wide. Next, we go and find our height, and we see that our height is 1, 2, 3, 4 units high. So our height is said to be 4. Again, because we're such great 4th grade students, we know that the area is found when we multiply our base times our height. So if we know that our base is 6, we can say the area is equal to 6 times 4. And we know that, right, that's an easy math fact, we know that our area is 6 times 4, that's 24, and this would be square centimeters. But our original question is, how do we find the area of a triangle? Let's focus just on triangle A. What would be the area of triangle A? Because 24 square centimeters, that's the area of the entire parallelogram. What if we removed triangle B and took a look just at triangle A? Let's go ahead and delete triangle B at this time. And let's go ahead and see maybe if we can make any connections. Take B and let's just go ahead and delete it. And let's look back, maybe put it back. Are we noticing something? Are we noticing what fraction triangle A is? If you're saying that triangle A is 1/2 of that parallelogram, you are absolutely correct. And you notice that triangle A is 1/2 of that parallelogram. Taking this understanding one step further, if we know that triangle A is 1/2 of the shape of the parallelogram, then our area of triangle A must be 1/2 of the area of the parallelogram. So the area of our triangle A is 12, or 1/2 of the parallelogram's area. So triangle A is said to have an area of 12 square centimeters. Let's take a quick look at problem number 2 to get some more practice at how to find the area of a triangle. Again, if you cut out triangle C and D on Math Masters page 265, you're going to have two identical or two congruent triangles, C and D. And now I'm going to create these two triangles that you have, but I'm going to label them A and B. It's the same idea, don't worry about the labeling. So I'll quickly take our first triangle and clone it. It's the exact same size. Now we've got triangle A and B. And we know that they're identical, that they're the exact same size. And our first step to finding the area of this triangle is to arrange these two triangles in a way that creates a parallelogram. And if I flip B over and move it closer to A like this, I see that yes, now I've made a parallelogram. Both of my pairs of opposite sides are parallel to one another. And now I first find my base. My base appears to be 4 units long, and then quickly my height of my parallelogram seems to also be 4. 1, 2, 3, 4. My height is 4. So again, area of a parallelogram can be found by multiplying the base times the height, and our base is 4 and our height is 4, so the area of our parallelogram is 16. The area of the entire parallelogram is 16 centimeters squared, or 16 square centimeters. But again, today we're not worried about how to find the area of a parallelogram. That was rather simple. Now we need to find the area of a triangle. And let's find just the area of triangle A. So let's go ahead and just get rid of triangle B. Let's just go ahead and delete it. And we should be noticing something. We should be noticing a pattern about this triangle and the portion this triangle A makes up of the entire parallelogram. We notice that triangle A is exactly 1/2 of the parallelogram. So if the triangle A is 1/2 of the entire parallelogram, it would follow that the area of triangle A must be 1/2 of the area of the parallelogram. If the area of the parallelogram was 16 centimeters squared, then our area of triangle A must be 1/2 of that. And it is. The area of triangle A is 8 square centimeters.